All right, good afternoon, everybody. Okay, so today we want to do a brief work on fluid mechanics. Okay, so fluid. So when you talk about fluid, all liquid and all gases are called fluid in physics. All right, fluid is defined as liquid and gases. So the aspect of fluid is divided into two different aspects. We have hydrostatics and we have hydrodynamics. All right, so the word suggests its meaning. So hydrostatics is the study of fluid, all right? Let's say liquids at rest, all right? While hydrodynamics is what is liquid in motion or fluid in motion. Okay, so the aspect I want to deal with first of all is the aspect of hydrodynamics and hydrostatics. Then eventually we'll talk about hydrodynamics. The hydrodynamics is where you do your fluid mechanics and the like. So hydrostatics, which is fluid at rest. Now, fundamentally, there are parameters that cannot be neglected when you are talking about fluid, all right? For instance, every liquid has a density, okay? So we have density, and density is rho, which is what? Mass over volume, okay? So we have basically mass, all right, over volume for what? For the density of every fluid. So if rho, which is density, is equal to mass over volume, all right, then rho over 1 is equal to m over v. So you cross multiply, you have rho v is equal to m, all right, or m is equal to what? Rho v. That is like equation 1. So if you are asked to determine the density of, all right, of a fluid, use mass over volume, but the mass is density multiplied by volume. Then the other terminology that cannot be neglected when you are talking about what? When you are talking about fluid is what we call pressure, and pressure is force over area. Okay, pressure is force over area, that is F over A. So we can write it as P is equal to F over A. So if P is equal to F over A, you have P over 1 is equal to F over A. Alright, so you cross multiply, you have PA is equal to F, alright, which is equation 2. Or F is equal to PA. So you have 4 is equal to pressure multiplied by the area. That's second equation. So you can use that. And from this, what we do basically, alright, is the Pascal theorem. Pascal theorem is taken from that value. So from pressure is equal to force over area. So pressure is constant because Pascal principle in fluid or in hydrostatic states that the pressure applied, all right, in an enclosed or in a fluid enclosed in a container or in a vessel is transmitted equally or in equal proportion through the walls of the containing vessel. That is what Pascal principle states. It states that the pressure applied on a fluid enclosed in a vessel or in a container or in a vessel is transmitted equally or in equal proportion through the walls of the containing vessel. So from pressure is equal to force over area, I've given density to be mass over volume, which is m is equal to rho v, and I've given pressure to be force over area, which is pressure times area is equal to force, or force is equal to pressure times area. So Pascal principle, all right, from what I stated is P is equal to F over A. All right, that is F over A now. So you now split it into two different forms. So you have F1 over what? A1 is equal to what? F2 over what? Over A2. So F1 over A1, all right, is equal to what? F2 over what? Over A2 is the expression of what? Of Pascal principle. And your A can be calculated using pi r squared. Okay, if you are given one area and maybe you have to look for the other area, just use A is equal to pi r squared. And you know that if diameter is given, maybe in a question, of course you know that if your SI unit is in centimeter, that's for the context of diameter or radius. You are going to convert from centimeter to meter before you apply it. But this how to calculate for area. So assuming I give diameter to be 10% and I give maybe initial area to be 10 millimeter square, you convert from millimeter square to meter square, which is divided by 10 raised to power 2. Okay, then for area you use per r square, diameter is 10 centimeter, then from centimeter to meter is 10 divided by 100. So use radius is equal to diameter over 2. So if you are given a diameter, divide that diameter by 2 to have your radius. So impute the value of radius in the value you have. So use A is equal to pi r square. Basically, that is how to go about that. Alright, so that's like the first area, alright, you need to take note of. That is Pascal theorem. Now, the other thing you need to take note of is other supplementary value for pressure. So we said pressure is equal to force over area, and force in fluid is mass times gravity, mg. Okay, if F is mg, now you can now write your pressure to be F is now mg. So you have mg over A. This is where Alright, F is equal to mg. So if this is the case, then your pressure is equal to, your mass has been expressed in the first equation to be rho v, so you now have it as rho volume multiplied by gravity then over area. So pressure is equal to, what is v expressed as? Volume is length times breadth times what? Times height, and length times breadth alone will give you area. So where a is equal to length times b, so you now have the final volume to be a multiplied by height. So that means anywhere you see volume, it is a times height. So you have rho multiplied by area times height, right, times gravity, then everything over area. So if that's the case now, then area is going to cancel out. Okay, so if area cancels out, your final formula for pressure, or what we call atmospheric pressure, is given as P is equal to rho GH. Okay, that's what you're going to be having. That's like the third equation. Okay, so now, alright, so we said that pressure is equal to rho GH. Okay, so now the next part, alright, is how to calculate for the work done. So in case you are asked to calculate for work done, W, alright, so work done, we call it, work done in fluid is, work done is force time distance. So what is work? Work is force time distance. So for work, I said F is equal to mass times gravity. So you have what? Mg multiplied by S, and distance is equal to length, alright? So they have what? W is equal to what? Mg multiplied by the length of the object. And once this is F, alright, F is what? F is pressure times what? Times area. Okay, so because in terms of the pressure, we have P times A. So if it's P times A instead of mg, because if you go this route, it's still the same thing you're going to get. But instead of that, we can just impute the value of W directly. So if F is PA from pressure is equal to force on area, so what I'm going to be having is that W is equal to, your F is now PA multiplied by S, and I said S is equal to length. So you have W is equal to PA multiplied by the length of the object, and A times length will give you, A times length or height will give you volume. Alright, so W is equal to, what we have, PA times what? Times PA will now, PA times either H or A times L or A times H will give you the value of volume. So you now have W is equal to what? Is equal to PV. This work on equation 5. That's how to calculate your work done in fluid, alright? Or you have it as change in W, alright? Is equal to what? P change in what? Change in B. Okay, you are done. That is the fundamental analysis of that. So now there is also what we call, alright, Archimedes principle. Archimedes principle actually talks about the fact that when an object is completely or partially immersed in a fluid, it experiences an upthrust which is equal to the weight of the object displaced, alright, by it. Okay, I'll come again. Archimedes principle states that when an object is completely or partially immersed in a fluid, it experiences an upthrust which is equal to the weight of the object displaced by it. So what is Archimedes talking about? Now there's what we call principle of flotation in physics, alright, in fluid mechanics, principle of flotation. So in principle of flotation, okay, so we have upthrust. Upthrust is the upward force, alright, experienced by any liquid, alright, upward force. So that's what we call upthrust. I said upthrust is what we call what? Upward force, or the force of buoyancy. Upward force, or the force of what? The force of buoyancy. Okay, buoyancy. Okay, that's what upthrust is. So now there are two major terminology we are going to be using if we are talking about upthrust. The first one is called the upthrust. The one is talking about the weight in middle of flotation. So if upthrust, alright, is less than or equal to the weight of the object, or weight of the object is less than or equal to the upthrust, then the object will float. Alright, it will stay on the top or on the surface of the fluid. But if your weight of the object is greater than the upthrust, the object will sink. These two different things is what we call the principle of flotation. It suggests that if the object is denser than the water, alright, or is weightier than the water, it will go inside. But if the weight of the object, which is maybe a stone, now if you displace a stone inside maybe a river, okay, so if the object sinks, it suggests that the weight of the object is more than the upward force, which is upthrust, which is the upward force. But if the weight of the object is less than the upthrust, alright, it will stay, alright, on the surface. That's what we call the principle of flotation. So this is what we call the basic, alright, or the fundamentals of what? Of hydrostatics. Okay, now when you now come into hydrodynamics, okay, which is now, because hydrostatics I said is what? Is fluid, Alright, at rest, while hydrodynamics is fluid in motion. Don't forget that I gave you Pascal principle to be F1 over A1 is equal to F2 over A2. Okay, and I said that sometimes they will give you two force. Alright, they can give you one area, maybe 10 millimeters square. Alright, so to convert from millimeter square to meter square, let's say area 1 is given. Alright, so you have 10 over what? Over 1000, then all raised to power 2. So you have A1 is equal to 10 multiplied by, now 10 divided by 10 raised to power, this raised to power 3 already, so that is 10 raised to power 3, then all raised to power 2. Then A1 is going to be 10 over 10 raised to power 6, so A1 is going to be 10 multiplied by 10 exponential minus 6, then all into meter square. But if you are giving, let's assume that this is what you are giving, and you are giving diameter of 1 to be 10 centimeter. What are you going to do? Convert that diameter. I'm just assuming that is 10 divided by what? 100. Then you have 0.1 meter. So if diameter is 0.1 meter, to calculate for area 2, use what? Pi r square. So A2 is equal to pi is 22 over 7. Alright, so you have 22 over 7 multiplied by your radius now. What is radius? It's the only diameter that is given. So if it's radius is given, alright, find the radius square after converting to a standard unit. But if it's diameter that is given, use diameter over what? Over 2. If radius diameter over 2, then you now have it as what? You have converted diameter to be 0.1, so you have 0.1 divided by 2, then it's all into square, so you have A2 is equal to pi is pi, r square is now diameter over 2 because radius is constant, diameter over 2, so your diameter was converted to be 0.1, alright, divided by 2. Okay, so then all into square, because of the square the formula is having, that is now 3.142. Alright, then 0.1, alright, divided by 2, all into square, 0.1 square divided by 2 square, whatever you have, you write it. So that's 0.1 square over what? 2 square is 4. Or you can just use A2 is equal to what? Pi r square, where r is equal to diameter over 2. So you have A2 is equal to what? Pi diameter over 2, because r is not diameter over 2, all into square. Then area 2 is equal to pi d square over 2 raised to